Welcome back to The Explainer. Now, if you tuned into that recent Spain versus France semifinal, you already know it was an absolutely incredible match. But what if I told you that what we watched unfold on that pitch wasn't just a game of football? What if, hiding in plain sight right beneath the tactics and the tackles, was an entirely different discipline? Today, we're going to look at this match through a completely unique lens. We're going to see how this game was actually a brilliant, real-world demonstration of electrical circuit theory.
Okay, let's dive right into this because the premise here is just fascinating. You see, Spain didn't just outplay France by having, slightly better footwork or catching a lucky break. Nope. They won because they essentially designed and executed a vastly more efficient electrical network right there on the field. As we'll see over the next few minutes, this whole match was really a story about voltage, resistance, and mastering the flow of current.
Part 1. France as the series circuit.
So to truly appreciate Spain's brilliance here, we first have to understand France's attacking strategy and ultimately the fundamental flaw they brought to this match. I want you to imagine France's attack as a series circuit. Now in a series circuit, electricity only has one single path to travel. There are no alternate routes, no backups. If one component fails, or if a wire gets cut, the entire circuit completely shuts down. The lights literally go out. Now compare that to how France actually played. They relied super heavily on just one primary attacking route, so whenever Spain stepped up and successfully blocked that main channel, France's attack just stopped. Because they were operating like a series circuit, taking away that one main pathway effectively broke their whole system.
And that brings us to this beautiful application of basic physics right on the football pitch. Let's talk about Ohm's law for a second. Current equals voltage divided by resistance. In our football analogy, France actually generated plenty of voltage, right? They had the raw power, the energy, the intent to score. But Spain? Spain steadily and systematically cranked up the resistance. They closed down spaces, tracked back relentlessly, and made it incredibly difficult to connect passes. And according to Ohm's law, when you increase the resistance, the current drops. So, because of Spain's high resistance, very little of France's attacking current actually ever reached the final third of the pitch. Their raw power was just mathematically neutralized.
Let's move on to part 2 and see how this builds. Spain, the parallel circuit.
The contrast with Spain's tactical setup is where this really gets exciting. Spain played exactly like a parallel circuit. Now, a parallel circuit is fundamentally different from a series circuit because it's divided into two or more paths. The beauty of this kind of design is that if you block one path, the current doesn't stop. It just immediately finds another route. And this perfectly mirrors how Spain attacked. If France closed down the left wing, no problem at all. Spain seamlessly shifted the current and attacked down the right. If France pressed the midfield, Spain bypassed them with these rapid-fire combinations. You block one player, another instantly appears in space. The attack literally never stops.
And this right here brilliantly illustrates the ultimate difference between these two teams. Look at this comparison. You've got France, a single pathway facing high resistance, making them highly vulnerable. Then you have Spain, multiple pathways creating built-in redundancy, making them incredibly reliable. I mean, there is a very good reason engineers build critical infrastructure, like hospitals, data centers, and massive power grids using parallel systems. Redundancy creates reliability. You just can't afford for a hospital's power to go out because one single wire fails. Spain essentially brought that exact high-reliability engineering advantage directly onto the football field.
Which takes us to part 3, building the grid and those complex systems on the pitch.
So, we've established the basic circuits, but what's really interesting here is how perfectly these complex electrical systems align with actual football positions. Every national power grid needs a control center, right? A place that distributes electricity safely and efficiently? Well, that was Spain's midfield. They acted as a literal power substation. Instead of forcing risky, low-percentage passes, they regulated the flow of the entire game. Sometimes they'd spike the tempo, sometimes they'd slow everything right down. Engineers call this load balancing. Football coaches just call it controlling possession. It is the exact same principle. In Spain's famous passing triangles, that is simply electricity naturally finding the path of least resistance. Now, of course, France didn't just sit back and watch this happen. They aggressively pressed Spain to try and win the ball back. In electrical terms, we can look at this intense pressing as an attempt to create a short circuit. A short circuit is an abrupt interruption of normal current flow, and if it works, the whole system crashes. But Spain responded to this disruption brilliantly. Instead of panicking and letting their system go down, their quick movement and dynamic passing just redirected the current effortlessly. They completely bypassed France's attempts to short out their rhythm.
But look, even the best designed networks experience dangerous spikes, and every electrical system needs protection. Enter the circuit breaker. A circuit breaker is an automatic device designed to stop the flow of current when a circuit becomes dangerously overloaded. On the pitch,
The Spanish goalkeeper performed this exact role. Whenever France actually did manage to string together a dangerous attack that threatened to overload Spain's defensive grid, the goalkeeper safely stepped in and interrupted the threat. No overload, no system failure. Thanks to their human circuit breaker, Spain maintained stable, continuous operation for the entire match.
Finally, Part 4, Spain's smart grid teamwork.
To really capture the full picture of Spain's cohesive structure, we have to look at the absolute pinnacle of modern electrical networks. Modern systems aren't built around one single giant power plant anymore. They use what are known as smart grids. A smart grid features multiple different generators, an array of sensors, constant communication, and incredibly adaptable routing. And Spain looked exactly like a smart grid out there. Every single player was communicating. Every player supported the guy next to them, and crucially, anyone could become the next source of power. Their smooth, flowing football happened because the system itself was vastly bigger and way more adaptable than any one individual player.
So, it really all boils down to this one crucial point. France generated plenty of voltage, but Spain mastered the flow of current. Why did Spain come out on top? Because France depended on a limited number of attacking channels, a series circuit that completely fails the second a single connection breaks. Spain, on the other hand, built a flexible, redundant network with multiple pathways. They behave like a parallel smart grid that just keeps delivering power, even when one path is completely shut down.
As we wrap up this explainer, I want to leave you with this thought. Football isn't just 22 players chasing a ball around on the grass. When you really, truly look closely, it's physics. It's network theory. It's literally electrical engineering in motion. I hope this breakdown gave you a totally new way to appreciate the beautiful game. And honestly, it leaves me wondering about our next deep dive. So what do you think? Which engineering concept should we use to explain the next big match? Should we look into control systems, thermodynamics, or maybe artificial intelligence? Think about it. Thanks for joining me for this explainer, and remember to keep looking for those hidden structures in everything you watch. See you next time.